In the previous section, we talked about finding the 6 trig functions of theta for any terminal side. But for this video, we're going to focus on special quadrantal angles. In section 1.1, you defined quadrantal angles as angles whose terminal side laid on either or ended either on the x or the y axis. So let's say that we have some point here given by the ordered pair 1, 0. In other words, it is 1 unit out away from the origin. And as I rotate this point around this circle, when it comes here to the top, we have traveled a distance of 90 degrees. So we want to write that on here. If I have traveled a distance of 90 degrees, and as my point is traveling, continues to travel around, when I land over here on the x-axis again, I've traveled 180 degrees. And if I keep on traveling and land back down here on the y-axis, I would have traveled 270 degrees. And then if I continue to go around and I'm back where I started, I will have traveled 360 degrees. And I need to point out that if I don't go anywhere to begin with, before I ever started, I had traveled 0 degrees. So we know that there's 360 degrees in a circle, and as I travel around the circle, when I hit these special spots, I have traveled either 0, 90, 180, 270, or 360. Well, if my ordered pair here, if I haven't traveled any around the circle, or if I completed an entire revolution, the ordered pair here would be at 1, 0. If I came up here to the 90-degree position, my ordered pair for this point up here would be 0, 1, right? Because I went 0 in the x direction and 1 in the y direction. Over here, this point at 180 would have the ordered pair represented as -1, 0. And this ordered pair down here would be 0, -1. So the ordered pairs are special when we want to talk about our quadrantal angles of 0, 90, 180, and 270. So it's really easy then to be able to apply that to the 6 trig functions. So let's do that. So in my first example, I want to find what the 6 trig functions are for the angle 360 degrees. So let me go back up here, because all I really need to know right now is this ordered pair for 360. Now think about this for just a second. I know that, I'm going to kind of write it down here at the bottom, I know that the ordered pair is 1, 0 for my 360 degree measurement. So I know the x and I know the y. What is the r value? In other words, how far is this point from the origin? Well, if we start at the origin and we move along the x-axis, it's 1 unit out, right? I only went out 1 right here. So anytime I am looking at this, the r is going to be this value out to the edge of the circle, if we're thinking quadrantal angles. Of course, I could always calculate that using Pythagorean's theorem, I suppose, but we're going to copy this down as my x value is 1, y is equal to 0, and if I didn't know what I just explained to you, I could find r by taking the square root of my x value squared plus y squared, which is 1, plus 0, which is really just 1, and the square root of 1 is 1. Okay, so we know that r is equal to 1. So we want to go ahead and we're going to figure out what the 6 trig functions are based on our definitions that we learned at the beginning of this lesson. So let's just start off by looking at sine, cosine, and tangent together. I know that the sine of theta is equal to y over r, and in this case that would be 0 over 1, which is really just 0. Cosine of theta would be x over r, which is 1 over 1, which is 1. Tangent of theta, that's where we have y over x, which would be 0 over 1, which is 0. So you stop the video and figure out what the remaining three trig functions are for this value that we have going on right here. We'll come back and we'll see if we get the same answers. So here I have the remaining three trig functions, and remember that the cosecant of theta will be given by r over y. Well, r over y gives me 1 over 0, and hopefully you remember right now I cannot have 0 in the denominator, therefore that's undefined. Secant of theta would be r over x, which is just 1. And cotangent of theta, which is x over y, gives me a 0 in the denominator again, and therefore this is undefined as well. So you want to watch out on the quadrantals, or you want to watch out any time you end up with 0 in the denominator, because that would give you an undefined function. So this next example we want to look at says, I want to find out if I have an angle theta in standard position with the terminal side moving through the point 0, -5. Again, I want to list the 6 trig functions. When you're doing trig, the best thing that you can do is draw a picture. It doesn't have to be perfect, but it'll help to kind of visualize what it is that they're asking. So I just drew an x and a y axis here. I have the point 0, -5, which I'm going to put on my graph. So if I go 0, -5, then that means I'm down here. And I have an idea now of what I'm talking about. Okay? So I know that theta is moving in this positive direction. It ends down here. Its terminal side is down here along the y-axis. And therefore, I know that x is equal to 0, y is equal to the -5, and r, again, remember r is really just the distance from the origin down to my point. Well, that is a length or a distance of +5. So using those three measurements, or those three values right there, find out what the 6 trig functions are for theta that pass through this point. Pause the video and try that on your own. Okay, so coming back and looking over this, when I look at sine, cosine, and tangent, I end up with -1 for sine, 0 for cosine, and notice what I get for tangent. I get undefined because x was in the denominator, giving me a 0 in the denominator, and therefore my function is undefined. So I can use kind of this section right here to be able to determine what the remaining 3 functions are, because they're just the reciprocals of what I've already found. The cosecant of theta is just going to be -1. Secant theta, well, when I take the reciprocal, that's going to put 0 in the denominator for me, and therefore my function would be undefined. And here, if I were to take the reciprocal of this, 0 turns to the 0 is going to move to the numerator, giving me just 0 for the function. Okay, so see how I can take the first 3 trig functions, calculate them out or figure them out, and then take their reciprocals, and I get the remaining 3 trig functions. Now, because we are starting to slowly memorize the trig functions and certain values for the trig functions, there's an empty chart here that I want you to take the time to fill in. And what the chart says is that if I take the sine of 0, I get back what? Well, remember that the sine, when I take the sine of a function, I'm looking at y over r. Okay? So if I look at the degree 0, the ordered pair for 0 is 1, 0. And out of that, I can come up with the sine of theta. That would give me 0 in the numerator, because that's my y value, and 1 in the denominator, because r is the distance. So the sine of 0 over 1 would be 0. Okay, let's look at cosine. Cosine is x over r. So my x value is 1, my r value is 1, giving me the cosine of 0 at 1. Tangent. Tangent was y over x. So y is 0, x is 1 for this degree of 0. Y is 0, x is 1, and therefore the tangent of 0 is 0. Okay. Cosecant. Remember, cosecant is the reciprocal of sine, so this is going to be r over y. Well, y is 0, and therefore this is undefined. Secant would be r over x, which is 1, and cotangent is x over y, and remember we said y is 0, so this is undefined. Okay, so that's how you would do this for each one of the rows. I would like for you, because you've got to start memorizing this, so stop the video, fill in the remainder of this chart just the way I did for 0, and we'll come back and we'll check our answers. So here I have the chart, the remainder of the chart filled in. Okay, check your answers with what I've got, but you're going to want to start memorizing that when I say the sine of 90, you come back with 1. If I asked you for the cosine of 270, you come back with 0. The rest of your trig will be so much easier if you start to commit these values to memory. Okay, let's look at one last example where we're going to apply this information that we had in the chart by evaluating an expression given certain degree values. So if I'm asking you to evaluate the sine of 90 times the cosine of 0 and add that to this cosine of 90 times the sine of 0, you've got to be able to recall the chart that we have up there. So the sine of 90, in case you don't remember, is 1. The cosine of 0 is 1. And I'm going to add that to the cosine of 90, which is 0. And I multiply that times the sine of 0, which is also 0. And therefore this is 1 plus 0, or 1. Okay, now, you can look back and you can look at the chart just to make sure that we have that all going right. But I can tell you right now you're going to want to memorize that. Okay, let's look at this next one. This next one says the cosecant squared, that's how we write that. So the cosecant squared of 90 times sine squared 270. So the cosecant of 90 is 1, but I'm going to square it. And I'm going to multiply that times the sine of 270. The sine of 270 is negative 1 squared. So this is 1 times a positive 1, which is again just 1. So these are just applying what we know by that chart that you're going to work on memorizing.